Today we are going to learn a final way of how to solve a quadratic formula. As you know, we started by doing solving equations such as this first one here by factoring and setting each parenthesis equal to 0. And then we did look at graphs of quadratic functions, the parabolas, and saw where they intercepted the x-axis, and those were the places that the function would equal 0, because y is 0. But what do we do when it can't factor? So we could have a graph that looks like this, right? Where we have our two solutions. But what if those solutions aren't crossing right at whole numbers like 2 and 4 and 5 and things like that? Well, if that's the case, then we have our last-ditch effort, the quadratic formula. Now, some of you will probably love the quadratic formula because it's a one-stop shop. It works no matter what. But it is a bit tedious. When you look at it, it's quite the equation, and I guarantee by the end of your assignment today, you will have memorized this formula. Now, to help you memorize this formula, there is a little song that goes with it, To Pop Goes the Weasel. So you'll see why I'm not the choir teacher and a math teacher. The song goes, x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. One more time. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, I apologize right now for getting that stuck in your head, and hopefully you'll be singing that tune as you write it each time. So let's take a look at this first example. We've talked before about a is in front of the x squared, b is in front of the x, and c is the constant. So let's define a is 1, b is -6, c is 5. So in our formula, I'm not going to rewrite it. We've got it up, but I'll say it. X equals opposite of b plus or minus the square root of b squared. So I'm just going to write 36 minus 4ac all over 2a. So there we go. So simplifying, we get 6 plus or minus the square root of 36 minus 20, all divided by 2, which is 6 plus or minus the square root of 16 divided by 2, which is 6 plus or minus 4 divided by 2. And so now we have to find our two answers. And so we have to look at 6 plus 4 divided by 2, which is 10 divided by 2 or 5. Or it could be 6 minus 4 divided by 2, which is 2 divided by 2 or 1. So our final answers are x equals 1 and 5. And there we go. Now, you might be asking yourself, well, wait, Mrs. B, we could have just factored that, right? This could have been x minus 5, x minus 1 equals 0 and done it that way. You're right. But if I started you off with the crazy square root ones, then I don't know, it just would make everything a little bit harder. So we start by introducing the quadratic formula with nice answers. But as you'll see, we really need it when it comes to the not so nice answers, where our answers involve a square root. Well, let's take a look at the next one here. We're going to define a equals 2, b is 5, c is -12. So x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so simplifying now, plus or minus square root 25 plus, watch your negative signs, right? Because it's minus 4, but then we have the negative 12. So 48 times 2 is 96, all over 4, which is negative 5, plus or minus the square root of 121 over 4. Now, 121 is a perfect square, so this is going to be negative 5 plus or minus 11 over 4. Now we simplify. So negative 5 plus 11 divided by 4, which is 6 over 4, which is 3 halves, okay? And then, so that's one solution. And then we have negative 5 minus 11 divided by 4, which is negative 16 over 4, which is negative 4. So x equals 3 halves or negative 4 are the two answers. So you can see this one was factorable as well, but we would have had to do the box. So the question is, and you'll have a choice on the homework tomorrow, and that is, do you do the box or do you do the quadratic formula? We got a problem with this one. It's not equal to 0, right? So we're going to subtract 15 from both sides, and we're also going to add 11x to both sides. So I'm going to rewrite this as 2x squared plus 11x minus 15 equals 0. And then we're going to define a is 2, b is 11, c is negative 15. And we plug in x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There we go. So simplifying, negative 11 plus or minus the square root of 121 plus 120 all over 4, which is negative 11 plus or minus the square root of 241 over 4. Now, you might think, oh gosh, there's a square root. Well, in this case, that square root of 241 is a perfect square. Not a perfect square, sorry. It's a prime number. It's a prime number, so it can't be simplified. So when it's like that, you can leave your answer just like that. Let's look at one more example. A is 2, B is 10, C is negative 18. Oh, actually, I'm going to take all that out. And do you see how in this, and this will help us make things a little simpler, do you see how these all have a factor of 2? So if we factor out a 2, that gives us x squared plus 5x minus 9 equals 0. And so if we do that, we can just do that part. And so in that case, A is 1, B is 5, C is negative 9. So x equals opposite of B plus or minus the square root of b squared minus 4ac all over 2a. Now, had we not factored out the 2, we would have had to simplify more at the end, which is not fun. So factoring out that common factor of 2, you'll see we'll simplify things a lot more, and we don't have to simplify at the end. So this is going to be 25 plus 36 over 2, or negative 5 plus or minus the square root of 61 over 2. Now, 61 is a prime number as well, and so we're done. But you can see now why we need the quadratic formula for our last two examples, because we could not factor that or do it, a box or any other way. The only way we could get those answers is by the quadratic formula.